os parece bien, bienvenidos, bienvenidas a todos. Gracias por estar aquí y por dedicarnos este ratito de vuestro tiempo. Así que cuando quieras, Javier.
Vale, hola, gracias Elena. Bueno, hola a todos, bienvenidos. Mi nombre es Javier Martínez, soy ingeniero de datos y llevo programando en Python ya un tiempo, ¿no? Entonces, es algo que, digamos, puede ser mi campo de expertise, aunque, como le decía Elena antes, pues yo siempre voy aprendiendo y, claro, el ecosistema es muy grande. Sorry, by the way, because I started in English and I promised that I will do this in... I started in Spanish and I will do this in English, so sorry. This will be the whole workshop will be in English. Thank you very much for coming. As I said, my name is Javier, and I will like to guide you through these three mosqueteers. So first of all, I hope all of you have access to the repository. If not, I leave the link in the chat, and I also leave in the chat the link to a Google presentation, just if you want to have access to it. Okay, so far so good, people, more or less.
Yes, cool.
Are you more or less ready? Good. So let's start a little bit. So the Three Musketeers. Why the name? Yes, maybe you can say that this is a clickbait, but it's more just for you to remember this session instead of giving the name of different packages or libraries. Three Musketeers can really pop up in your mind in the future. And it's not unrelated to what we are going to see today, because my goal is that we go through three different solutions, frameworks that one can use in the Python environment when it has to deal with web-based applications and have to deal with costly operations and concurrency. Okay, and let's see what is the problem or the initial problem. Let's say that we have a group of users, as you can see here, at the left, and we want to develop an application that is web-based, so the users will access through HTTP request, and we want that this application provide the number of COVID-19 cases based on the currency of a given country. So the users tell us US dollar, and our application return the amount of cases per country that use US dollar as a currency. Okay. During the whole presentation, I will use euros because there are more countries that use euro as a currency, and we are in Europe, and well, it makes sense. Nonetheless, this is a toy example. Probably this is not really useful, but nonetheless, it's helpful for the topic and the topics that we want to address today. So the problem with our application, or maybe the main dependency, is that for getting the information about the countries and the COVID cases, it made use, as you can see on the right side of the screen, I think it's the right for me, made use of two APIs. One API for getting the countries based on the currency. So we asked this API, hey, I want to know the countries that use euro, and the API returned the list of countries. And the COVID-19 API that based on the country returns all the records of cases per day, and we take just the last day. Okay. In theory, this should work, but in practice, usually this means that we have no control on the time on these APIs. It has some serious implication, or could have potential serious implications, because for accessing to this information, we need to perform costly operations, which are network operations. You can change this API by other costly operations, like accessing a database or accessing other resources that are really costly in time. Okay, so far so good, more or less.
Yes.
People, good. One common setup that I have seen in the industry, in the community, is this one. Okay, we have in blue our application, and we set it in a server where Nginx is the web server and is reverse proxying the request to our application that is using Flask. Okay, Flask is really widespread for MVPs, for people that are starting. So instead of using something really heavy like Django, people use Flask. And in between these two, we have a Unicorn, that is the web server gateway interface, which basically is taking the request and translated this HTTP request to the Flask endpoints, to the functions. Okay. As I said before, this setup is kind of okay, but has to deal with these two thunders or delays that affect the communication with the APIs. What we know from computer science and our own experience in life is that, okay, if this can take a lot of time, and maybe I can to serve or provide service to many users, I can try to use parallelization. There are different kinds of parallelization. We can use more cores and increase the number of CPUs. We can use more threads, and we can use what is called concurrency. Okay. Process and threads scale much worse than concurrency. Nonetheless, I think, I'm not sure, but you can confirm me, to me that Apache use threads for serving the different requests instead of using concurrency. But the advantage with concurrency is that we can scale, and also that we have the ownership of the parts of the code that will make use of this concurrency. Are you aware, more or less, of what concurrency means? Or not?
Yes. At least
Okay.
me. Yes.
Christian, yes.
Sofía
Xavi,
dice no. Moisés
Sofía,
dice
no.
yes. Seri
Okay.
dice no.
With one no, it's okay. So it's enough. So concurrency is the ability to do other tasks while you are waiting for another things to be done. In case of costly operations, for example, if you want to do a request to a API that is remote, you have to send that request through the network. Comparing to the operation that happens in your computer, this will take a long time. Okay. So concurrency is the capability of using that time, the time you are waiting, for doing different stuff. So let's say that you want to do something, you can start at one point, and instead of having an idle period of time, you will put another task while waiting. And when the result for this first task arrive, you can continue with that. Let me know if this example is more or less clear. because it's something that we want to take advantage of during the session.
Sergi dice que understood. Well,
Okay.
Sergi says that it's understood, so yeah. Please tell.
Clear, Cesar, Sofia, perfect. Everyone is on track. So let's jump to the code because we have too much PowerPoint and that's not good. So there are 4 branches in the repository. We have the master, which has only the README and the pip file. We have also the init branch. We have also, well, we have these branches, okay? So we will start, the master is useless, basically, it's just the README, and that's all. We will start in the init, we will jump afterwards to the Async IO, later on to the FastAPI, and finally to the Celery branch, okay? So for the first, let's go to the init branch. When I will close this, that is the README. In the init branch, these are the files. Can you see? Can you read the text and the editor?
The files are a bit small, but I think they can be read well.
Yes, Guillermo said yes, yes. Okay, then I will continue with this. Perfect, thank you, Moses. So in this case, we have a simple application developed in Flask that has only one endpoint, okay? This endpoint is get cases today, and we pass the currency in the path, okay? In this case will be euro. With this currency, what we are doing is calling our APIs. So first we get the list of countries that has that have this currency, and later on for each country we will get the cases for today. Okay, these 2 functions that use or make use of the APIs, I put it in the long task file. Why? Because they take long accessing the API, okay? And the implementation is just making use of the popular library or module request, accessing the URLs that are defined within the config file for the 2 different APIs, accessing the endpoint for the different API, and well, performing some cleaning, getting parsing, and getting the results. Okay.
Okay.
So if we try to run it, I will do. This is a preference, personal preference, but instead of entering the virtual environment, what I like to do is to use pipm run, which is from outside the virtual environment, run the command that you pass within the environment. I don't know if it's clear, but let's see. So this is the command that I'm going to execute. And what it's telling us is that Unicorn, the WSGI, the web server gateway interface, with 1 worker and a timeout of 1 hour, just to have enough time, will generate a server that is stored in the main file, and that is called app. Okay. So if we execute this, we have here Unicorn and listening on this port. Okay.
Okay.
For the sake of testing, I generate a client for benchmarking. Okay. You can enter if you want into the client version, but because I'm using Async IO, within it. I prefer to postpone it if you want, and I just tell you what it's doing. So basically, the client, what it's doing is generating concurrent users to our application, okay? And to get the executions of that, we can pip-emp in a different console, Python client.py1. And this number 1 or 10 or 1000 will be the number of concurrent users, okay? And if we launch this, we can see in the server console that our application is calling one by one the different countries, okay? At the end of the execution of the client, I put some statistics like the total elapsed time, the throughput, and the median duration of all the requests. And this plot is just, in this case, one plot for showing errors in case we have errors. In this case, we don't have. And then the amount of time per request, because we have only one request in this case, we have only one bar. And this is in unsort, so in the time that they happen, and this is sorted by computation time, okay? Just to see what is the arrangement, okay? Different requests. We can close it. And if we increase like 3, we can see, as before, that our application is calling the countries one by one, but also is serving the request one by one. So first, provide the information for the first request, and then for the second request, and then for the third request, okay? I know that this whole example is a bit dumb because you can cache the information and don't waste time every time. But it's for the sake of, okay, you want to do something that is really costly in time and you have to wait for it, okay? It's just that. In this case, what we will have is something similar. But now we have 3 bars because we have 3 requests, okay? You may notice that the time of each request is cumulative, or we accumulate the time because we cannot process one request until we finish the previous one. Okay, we don't have any parallelism in this case. So the elapsed time is relatively high. So one solution for mitigate this thing is what we have in the table before, that is try to increase the number of workers, okay? In Unicorn, the number of workers is given by this. There is a formula that is in the slides. Okay, I was reading the chat. So there is a formula, and more or less 8 workers is kind of okay. So we can execute it. You can see the different IDs for the workers, and if we execute it again with 3 concurrent users, you can see that just from the output from the console that all of them are running in parallel, and then we get the result much faster. Okay.
Okay.
Nonetheless, we still are lacking of power in the sense of we are still calling the API one by or sequentially. Okay.
Mm-hmm.
So one solution, we apply some parallelism here, increasing the workers, but we can do it better. And for doing better, we are going to use Async I. So we can git checkout to Async I branch, and all of this will disappear. Sorry, the typo. And we will have only one main file, okay? The reason for that is that before going to something more realistic, I want to do some theoretical example, okay? With something simple. What I want to do here is just to have two counters, okay? And I will introduce a sequential or traditional counter, and I will introduce a counter using Async I, okay? Async I is a framework that is really right now in the since 3.7 for sure, and now in the 3.8 is completely integrated in the Python standard library, but not many people are aware of it, and not many people, to my knowledge, make use of it. So, okay, we are going to have two counters. So I will execute. In this case, I need only one. This main, okay. This main executing like it is, it will run first the synchronous counter and then the asynchronous version. And you can see that in the code like here, okay. If we don't have any extra argument, the default amount of or number we want to count up to is 20. And we will run first the synchronous counter and then the asynchronous version. Okay. First thing that you may notice in the file. Okay, async count is here. Async count. So first thing that you notice is that the function for async count has a keyword before, which is async. And be ready for two keywords that are really used or are needed in the Async I framework, which are async and await. Okay, by async, what we are telling is that this function is not a regular function, but is something that is called a coroutine. And a coroutine is an object that can have concurrency. So it's an object that when it's awaited, the GIL, the global interpreter loop in Python, can put it away while waiting and execute a different thing, okay? And these two counters, within them, what are doing is using the count up to functions. So count up to has two versions, the synchronous with an S before, and an asynchronous version. Within the asynchronous, you may notice this await, and this is the second keyword that is important in the framework, because await is the keyword that tells Python that that block, that coroutine, should be await, and while we are awaiting for that, the global interpreter loop can do other stuff. Okay. So looking to the point in the code where we call it, we call the synchronous version, but here for the asynchronous we did something special. We did async.run, and you say, okay, why? And you say again here async.run. Okay, why I don't call it in a regular way, like we usually do, like this. Okay, so if we try to do this, and for this I will use these parameters. What we will have is a warning. A warning because Python is telling us, okay, this thing is not a function anymore, it's a coroutine, and that coroutine was never awaited. So when we have to work with Async I, one has to switch a little bit the mental scheme and the paradigm. So by putting this async before, that this is not a function anymore, it's a coroutine, okay, and should be run in a different manner. So if we delete this and go back, and we save, of course. Checking the previous execution, which is the default one, we have the synchronous counter, counting 1 by 1 up to 20, and the runtime is 26 seconds because we have in the counter a random sleep, okay. But we see that, okay, the asynchronous version did not perform better. Indeed, it is worse. And you may say, Javier, you are doing this bullshit. But yes and no. The first thing is that I lie because within the asynchronous version, this one, I just call the synchronous counter, okay? So we didn't gain anything. Indeed, we put an extra burden in the loop, which is taking care of this asynchronicity. So one initial second approach could be this. So we can have instead of calling the yes.
Moises is asking for a bit of clarification because he is quite new into that. So maybe you can just clarify why using these libraries. Just a bit to put the goal of the usage of these libraries.
Yeah, the goal of the usage, and sorry if I was not clear. If you remember in the previous branch, we had a problem that we need like 8 seconds for running things. Okay, Moises, or well, everybody. And what I'm doing here before moving to something more complex is taking a small example of Async I/O before using Async I/O with a framework. Okay, so you will see here the benefits and some patterns of Async I/O, and then we will view these patterns in the same context as the previous example with Flask, okay? In the case of a real web-based application. More or less?
Yeah. So at the end, what we will achieve is to be able to parallelize and to use better our resources in the servers. So we will be able to make more calls or use more power of the machine to be able to request this data, right?
Exactly. Thank you, Christian. Yes, and the idea of putting these sleeps is not because we need it for anything. It's kind of think the calls we have before to external APIs like these sleeps. So as I told you before, when we were calling external APIs, the loop was completely blocked, doing nothing. So in practical terms, it was similar to sleep. So that's the reason why we have here these sleeps. I'm missing the text. So, yeah.
Yes.
A ver, Sofía. Okay. So what this second approach is doing is kind of making calls and awaiting them to the asynchronous counter, okay? But if we execute this, what we will see is like it's starting in a similar way. It's kind of sequential, isn't it? It is counting 0, 1, 2, 9, And now, if you notice, okay, now we have a different counter, but both counters are running sequentially. And the only purpose of this is to show you how the things should not be done. So we want to get the real value of the asynchronous framework. So let's jump to this chunk of code. And let me explain it a little bit. With the coroutines, we can await them, but when we have a bunch of things that are independent between them, we can generate a list of coroutines and tell Python, okay, this is the list of coroutines. This is the list of things that can be awaited and run with concurrency that I want to execute. So this is the way to work, because then what Python will do behind the scene is to run one of the coroutines, and when that coroutine has to wait, we'll put another coroutine, and when that has to wait, we'll put another coroutine, and we don't have to take care of that. So with this set, you can see here that we are calling the asynchronous counter, but with no await. So at the end, going through this loop, in the task list, we will have a set of coroutines or tasks. And it's here in this line where the magic happens, because we are telling, okay, Async I, gather all these coroutines and execute them concurrently. I think this is similar to the promise all that you have in other languages like JavaScript, but probably many of you or some of you know better. So if we save and we go for it with, I don't know, 30, 35, I think. We will have, this is the list of coroutines that we will have. And as you can see, they are running in parallel in chunks of 10s. The reason behind why chunks of 10 is that I just divided or split it in chunks of 10. There's no more behind that. But you can see that we got the result much faster than before. Before we need 30 seconds to achieve 20, to count up to 20. And now to count up to 35, thanks to run the different coroutines concurrently, we are able to do it in much less time, okay? So now, the thing that we are going to do is to apply this to our previous example of the web server. And for that, let's check out to the FastAPI.
Okay.
Yeah, I don't want to change anything.
So divide and conquer, right?
Exactly. Divide and conquer always when you have independent things. Mm-hmm. So if I want to request information about something, a country, Spain, that cases are independent of Germany or France or any other country. Yeah. So this is something that we can use for concurrency. And one thing, thank you, Christian, for pointing this. Good thing of Async I is that it's really explicit. So as you have seen, you have to change a little bit the paradigm of programming. There are other libraries in Python like G-events or greenlets that provide also concurrency, are older because concurrency is nothing new, but the way of apply them is not so explicit. So it's not so obvious that what you are doing is running something with concurrency. Nonetheless, don't get worried because we continue. Now that we understand concurrency or the power of Async I/O, Async I/O or the concurrency was looked also for web servers gateway interface. If before we have a WSGI, now in the people develop the standard for ASCII, which is the asynchronous version of a WSGI. So it's ASCII right now. And one implementation of this is Ubicorn. In practical terms, imagine that it's doing the same thing as WSGI was doing before. And instead of having a Flask, let's have a FastAPI. And why Flask API? Because it's a framework that integrates much better async I/O or concurrency within. Okay.
Mm-hmm.
So this is what we are going to do now. As you can see, the structure of the application should not change too much. So if before we were declaring the application as Flask and calling the Flask method, we are calling now FastAPI. So it's similar. And if before we define an endpoint called getCasesToday, we have exactly the same endpoint, the same logic with some small changes to adapt it to FastAPI, okay?
Mm-hmm.
But on top of that, we are going to have this endpoint, and I mark it with an A before, and as you notice, it has the keyword in front of the function that handles the endpoint. So it's telling us that this is not a function, it's really a coroutine, as we have seen before.
Okay.
So good thing of FastAPI is that you don't have to worry too much about what is a coroutine or a function. So if you are moving something from Flask to FastAPI, you can use, as before, the functions that you have. But on top of that, you can define here coroutines, and this, or behind the scene, Flask API will make use of Async I/O to run these endpoints, okay?
Mm-hmm.
Sorry. So if we enter a little bit in the implementation of getCases, the asynchronous version,
Mm-hmm.
you can see some patterns that we have seen before in the Async I/O branch. You can see that now for getting the countries, the call to the API, to the countries API, we are awaiting. So this is something where the guild can be await and take the ownership of the guild can be taken by another coroutine.
Mm-hmm.
And in addition, on top of that, we have similarly an array of tasks that we will gather, and we will tell Async I/O, okay, I have this list of coroutines, each one for each country, or one per country. So run them concurrently, okay?
Mm-hmm.
And this is the point where we will gain a lot, as you will see. So the way of testing it is kind of similar. We can start the server. Instead of using Unicorn, we use Ubicorn, which is this ASCII. And for the client, we will have something similar, but let's do something. Let's run first the synchronous endpoint. So if I do this, we are accessing the classical endpoint, the one that we have seen before, okay? So everything is running sequentially, okay? We have more or less the same result. It's a bit faster nonetheless, but pretty much the same. Okay.
Okay.
Now, instead of accessing this synchronous endpoint, let's use in our client the A to use the asynchronous version. If we do this, you see that everything happens super fast. Why? Because all these calls for different countries is run in parallel. Mm-hmm. So not in parallel, but with concurrency, sorry. And let me explain it again. So when I'm calling, let's say, this is Denmark, this is, I don't know, France, Finland and France. When I'm accessing the API for Finland, I have to wait for that API. Before, we have to wait until we got the response. But now, I can tell, okay, France, send a request for France. And we can do the same with all of them. So we don't need to wait, okay? As you can see, we get a nice improvement in time and other benefits. I will speed a little bit up because I'm behind the schedule. So good things and bad things about this. Well, good thing is that we increase the user experience. And we increase the throughput that we have in our application. Bad thing is that we need especially implementation. Why? Because before we were using get countries and get cases today cases, which were traditional functions, but now we need to implement a synchronous version of the previous functions. And if we take a look, these are the previous functions. And the asynchronous version are already coroutines themselves, okay? So it's a slightly change of paradigm, but the developer should be aware of this. And another thing that provides extra work is that many of the libraries out there in the Python ecosystem block the GIL. Okay, so the popular request library, when it's doing a request, when it's getting a request, block the GIL. So despite we will put the request within a coroutine, like we saw before in the branch, we will block the coroutine in the same synchronous manner. So for avoiding this, there are coming more and more libraries that are implemented using the Async I paradigm or framework. In this case, this is AIO-HTTP, which at the end is really similar. I use here maybe a convoluted way of use the library, but it's not so convoluted. Indeed, this is syntactic sugar for something more complex. I leave the documentation right here in case you have any doubt about what is happening here. At the end, we are creating a session, and within that session, we await for a response, okay? Mm-hmm. And the response needs to be await, and interestingly also, the parsing to a JSON is also a coroutine, so we can await that there. Having more await is kind of beneficial because when you said or declare that you can await here, other coroutine can take that time of doing whatever and do other stuff in the GIL, okay? Mm-hmm. So we improve the performance. Mm-hmm. So this is the bad part of using Async I. Mm-hmm. FastAPI provide.
Javier, Moises is asking if all of this it's just with one thread.
No, not really. In the end, or behind the scene, Ubicorn is generating, well, FastAPI together with FastAPI is based on Starlit, which is another application, web application. So below the scene or behind the scene, for the synchronous endpoints, you have a thread pool that you are using. For the asynchronous, yes, I think you have only one thread. But if you have, you give the flexibility of providing synchronous and asynchronous endpoints, you need a way to take the synchronous and put them in a different thread for not blocking the asynchronous, the concurrency. Okay, more or less clear, Moises?
Yes, clearer. Thank you.
Okay, thanks for the question. And you will say, okay, but maybe what I have to do it costs a lot of time, and this is not enough. Then we are going to jump to the last point of this workshop meetup, which is the usage of Celery. It can happen that you can do something that requires a lot of time.
Drink a bit of water, man.
Yeah, it's super dry, isn't it? It's the time, it's a pressure. So imagine you want to do something really costly, like you want to fit a machine learning model. This can take a lot of time, isn't it? It can take minutes, and you don't, or it's really a bad user experience to have the user looking at the spin on the web browser for hours or for minutes. So in this case, in this setup, maybe the contract should change with the user. So if you have something that takes really long, we can tell the user, okay, instead of providing you the information right now, what I will do is you send me the request and I will give you an ID, and then you can come later on and ask me about the status of this ID, of this task. I will tell you what is the status, and when it's finished, I will tell you that it's success, and I will return you the data. So in this case, you can have, for example, the users implementing their own interface and asking every 5 seconds, hey, is my task ready? Did you do it or not? In this case, we will follow or continue with the example of the countries. Maybe this is too much, but but let's see how it is. So in this last case, let's check out to the Celery branch. And I will close the browser because I need more space for an extra console. So let's take a look. The implementation is similar to FastAPI, okay? We will not change that. We have, as before, 2 endpoints. We have the asynchronous and the asynchronous version, okay? But in this case, we need some new endpoints. And the way to keep everything clear, the way of doing it is I will put these new endpoints in a different file called Celery endpoints, and I will include these endpoints into the FastAPI application with this line, okay? It's nothing fancy, but just in case, I explain it to you. If we jump to the Celery endpoint file, the structure is similar. Instead of having an app, an application as before, we define this FastAPI object or structure, which is the router. And for defining the endpoints, instead of using app.get, we use router.get, but nothing changed. We have two endpoints. We have compute cases today is the endpoint that is going to implement this thing of, hey, process, I want this, I want you to process this thing. And as you can see within, is calling this long task enqueuer, and is telling that apply it asynchronously. We will take a look now to the long task enqueuer, okay? But just looking at this, something that Celery is taking care of. And the second endpoint is cases today, what is the status? And this is the endpoint where the user can come and send an ID, and the application will tell the status of the task, pending, start, failure, or success. Okay. Mm-hmm. For Celery, we need to define a Celery app because we can run it independently. So Celery app, this is a simple Celery file, but you can do something much more complex, of course. We define the function like my Celery. We pass the configuration for Celery using the Celery config. Within the Celery config, you can see the broker and the backend, both are ready. This is something that maybe is difficult to set up in your computers. If you have any problem, just reach me by email or so, because now we are a bit time constrained. But the Celery task, what it's doing inside, if you take a look, is calling the get countries function, synchronous function we have used before, which is still in the long task, okay? Mm-hmm. And then later on, calling to the synchronous get to the cases, okay? So basically, what we are putting within that task is the same code that we have before for the asynchronous version of the synchronous endpoint. Mm-hmm. So I have talked a lot, so let's try it. Pip end. We have the server. We can start. We can start Celery like this, and you will see in this beautiful banner that we have one task here, which is the long task enqueuer. And as before, we will have a client. In this case, the client will follow what I told you before, which is doing this process of getting an ID and then later on asking. So now it's running, and because it's the synchronous version, you can see that the server answered with a 200, so it's okay. Mm-hmm. The client is getting this ID, COVID app ID with a unique ID, and every 5 seconds is asking, and the answer of Celery, which is running here, is that the task start already, okay? Mm-hmm. So now we don't have to worry, we are not worried too much about efficiency, because we agree with the user that, okay, when everything is ready, you will have and you ask me, you will have a notification that the task is finished, okay? So as you notice, the Celery finished before, but because this is asking every 5 seconds, it's after this 5 second finish that the client get, oh, COVID, blah, 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 task finished, and it's a success, so I can get the information, okay? And the client will get that. Again, we are not so efficient because we need a lot of time, but we don't keep the user waiting for information, and we improve the user experience, in my opinion.
Mhm.
Saying this, and with this amount of time that I consume, there are many other stuff, but what I want you to know is that out there, especially in the latest with the latest version of Python, there are a lot of new frameworks that are popping up and using all the capabilities of the new Python. So I encourage you to use them, and don't be really afraid. Many of this stuff could have been done in a different way. Instead of using Celery or using FastAPI, it is worthy to take a look to Hypercon, which is a different ASCII, and other links or other ideas that I left in the repository.
Okay.
Saying that, I finish with this. I hope you gain in knowledge,
Yes,
to some
sure.
degree. And I'm open to any question, any comment, any idea. I would like to ask you, if nobody asks, well, I will wait for questions.
I have one question. Is which will be the use case, the most common use case that you will put this on? I mean, this is trying to solve a common problem in the industry, that it's that not blocking the user for the request, or not blocking the server with many requests. So, but in a real world, have you implemented that, and or any real use case that maybe can be this implemented on?
Yes, I have worked with this in data science. What I have done so far is more related with data science. So one of the idea I told before is like fitting a model. Fitting a model based on a given data set can take a lot of time, or some time. So one idea of using Celery could be for that. For concurrency, well, concurrency can be also can be used also in fitting a model, but the other case that is real is that in a previous company, we need to, or we depend a lot on calls to Gmaps, to the Gmaps API. Okay. So we need to decode geo points. We were using Gmaps. You can use any other third API. In addition to Gmaps, in that same solution or application, we need to use or get the estimated price of the transport, okay? Because it was a transport company. So these two services did not belong to our company. So we trust in third-party services. And these third-party services, you can see that the response time fluctuate a lot. And you have a strong dependency there. So because in these cases, many or geographical points usually are independent. You can have a logic, but are independent. You can make the call for one point and for the other concurrently. And you gain a lot. We gain 10 times the speed, or we speed up 10 times the application with this.
That's cool. Yeah, I don't know if anyone has any other questions.
I'd really like to thank Moises and all the people for the questions. And Come on, tell me something.
Don't be shy.
Don't be shy. Tell me, but why didn't you use Django? I don't know. Or what is the... So then I have a question for you, maybe. Are you, or the audience is familiar with Python? It's not familiar. I know Christian is not familiar.
It's the second time I see
But...
Python in place. I mean, I knew a bit of code. I checked a bit of code in the past, but I was not familiar with any, let's say, production code. So for me, it was easy to follow, but in the explanations, but hard to follow in the implementation. But it's a matter of knowing the language. So no worries from my side.
So I hope the people clone the repository and play with it if they are interested in this kind of stuff.
I hope so. Look, there is a question.
César tiene una pregunta, sí.
César? Yes.
César, is it better to use Celery with FastAPI or with Flask? I think it's a bit independent because you can apply concurrency in Celery. So the benefit of using Celery will not be affected too much. In any case, I would recommend FastAPI because you can implement both type of endpoints.
Mm-hmm.
So Flask has worked pretty well during years, but it still relies on WSGI. So I think new frameworks will take its place. It's okay, Cesar? Did I answer your question?
Yes, thank you. It's okay.
Okay, so I will stop sharing the screen.
Javier, si quieres que enviemos el repo a los asistentes, lo podemos hacer. No sé si habéis hablado de ello. Perdonad, me he tenido que desconectar un momentito. No sé si les puedo...
I'm really, well, I'm really open to share the repository. I encourage you to, open pull requests or send me questions there if it's easier. You have also my email in the repository. You have also the commands that I think you need for following the execution that we have followed. You have some interesting links, so feel free to play. And
yeah,
okay.
Thank you all for coming.
Te están dando las gracias por aquí.
Yeah,
Dice Sofía que ha empezado con Python hace un par de semanas. Esperamos que te haya servido, Sofía.
So my recommendation, be patient. I'm starting with Rust, and I feel like a newbie, like working with memory allocation and this stuff, which in Python I don't have to worry about. So take your time and thumbs up for starting with Python.
Yeah.
Pues si os parece bien, lo dejamos aquí.
Yeah, thank you, Javier, for the workshop. I really enjoy it, even though I don't have any clue with Python, so thank you.
Thanks to all of you, and yeah, I recommend to keep in touch with these people of Codurance. And
Muchas gracias. Gracias a todos y a todas por estar por aquí y regalarnos este ratito. Esperamos que os haya gustado.
See you next time.
Thank you. Bye.
Gracias.
Thank you. Bye.
Chao.